How we doing? Welcome back to the Practice 2012 AP Calculus AB exam that College Board put out, about a decade ago. We already did problems 1 through 10 in the first video. We're going to do multiple choice problems 11 through 20 in section 1, part A. We do not get a calculator, which is fine. Two things: follow me so you will get notifications when I put up the next videos for this test. That helps you. Then like this video because that helps me. And while you're down there ringing the bell, again, if there's anything you want to put in the comments for questions you want to see, questions you have about the work I've done, or tests you want to see me do, go ahead and throw that down there. All right? Let us take the next step in this journey, which is the 2012 Practice AP Calculus AB exam. Let's go. Number 11. Let f be the function defined by f of x equals the square root of the absolute value of x minus 2 for all of x. Which of the following statement is true? Well, if you know anything about absolute value graph, you know it looks like a V, and your corner is right at x equals 2. All right? But since we're taking the square root of this, it has a little bit of bend to it instead of straight lines. Okay? Without a calculator, how would I know that? Pick some points. Okay, pick some x values and figure out y values. And you'll end up with a graph, I don't know, that looks something like this, where this point happens to be, we'll do that in red, at 2, 0. Okay, that's where my cusp is. And because it's a cusp, I know I cannot take the derivative of it. So if I look at choice A, which of the following statement is true? 4 of them are false. 1 is true. A says f is continuous but not differentiable. That is 100% true right there. A cusp is continuous but not differentiable. B says f is differentiable at 2. That's false. It is not differentiable. It's a cusp. C says f is not continuous. That's false. A cusp is continuous. You just can't take the derivative. The limit as x approaches 2 is not 0. Oh, that's a big falsehood. Because as I approach from the left and the right side, it does approach a y value of 0. That's false, because it is equal to 0. And x equals 2 is a vertical asymptote. No, that's false. That's just where the cusp is. A is the only option that is true. Number 12. Using the substitution u equals the square root of x, okay, the integration from 1 to 4 of e to the square root of x over the square root of x dx is equal to which of the following? Okay, so it looks like we're just going to have to do like a little substitution here. They're telling us u equals the square root of x. So we've got to figure out what du is. Well, the square root of x is like saying x to the 1/2. The derivative of this is 1/2 x to the negative 1/2 dx. Now let's simplify that a little bit. Let's take our negative exponent and flip it. Put it in the bottom. So we've got 1 over 2x to the 1/2 dx. And again, anything to the power 1/2 is considered square root. So I'm going to say du equals 1 over 2 square root of x dx. If I look in my problem here, I have a square root of x in the denominator. That's cool. That's what I want. I have a dx out here. That's cool. But I got to get rid of that 2. So the bottom of the fraction, which we call the denominator. So if I multiply both sides by 2, that cancels. And now I've got 1 over the square root of x dx comes out. And in its place goes 2 du. So let's integrate this. I'm going to put my 2 on the outside, du. Okay, there's my 2 du right here. All right? That went in the place of my square root of x on the bottom and my dx. There, bye-bye. Now, what else do I need to put? Okay, well, again, u is going to be substituted in for the square root of x. So it's e to the u. Okay? So this goes bye-bye, my u goes in its place. The only thing that you have left to do deals with my bounds. What do I mean? These are x equals 4 and x equals 1. I need to convert them to u bounds. If x is 4, the square root of x, or in this case is 4, would be 2. That's my new upper bound. And my lower bound, when x is 1, I just take the square root of that x value, which is 1. The square root of 1 is 1. So here we go in all of its glory. That's what I should get when I do the u substitution, square root of x in for u. And it looks like C is the correct answer. Now, whenever they ask a problem like this where they give you the u sub, they always do something tricky where they have everything the same except the bounds aren't converted. I can't tell you the number of my kids that would pick B. All right? Look at D. They put a 1/2 out front instead of a 2. Okay? And for A, they squared the bounds instead of doing the square root. So there's always some mathematical relevance to incorrect solutions or answers or choices. So make sure you're careful, you take your time, and you pick the right answer, because it would be a shame to do all that good work and just circle the wrong answer. 13. There's two ways to do 13, and I'm kind of torn which way I'm going to do it. I think I'm just going to do an integral instead of actually graph this and do the area under the curve. 13 states the function f is defined by f of x is a piecewise function where f of x equals 2 for any x value less than 3, and f of x equals x minus 1 for any x value that's greater or equal to 3. What is the value of the integration from 1 to 5 of f of x? Now, I could graph this, and I'm going to end up with a couple of rectangles and a triangle, and I could really easily find the area under the curve if I graph this. But let's practice some integration, shall we? All right, first off, if I'm going to integrate this thing, it wants me to go from 1 to 5. Keep in mind, this thing splits at 3. So what I've got to do is I've got to go from 1 to 3. I got to integrate something, and then add that to the integration from 3 to 5. Because at this point, I'm going all the way from 1 to 3. Then I pick up 3 again and go straight to 5. That would cover from 1 all the way to 5. But the thing is, for this integration from 1 to 3, those are x values that are less than 3. So I'm going to integrate this part. I'm just going to integrate 2 dx. All right? And for the integration on the right side of the plus, my bounds go from 3 to 5. Those are values that are bigger or equal to 3. So I'm going to integrate x minus 1 dx. All right? These are very simple integrations, so this shouldn't be a very difficult problem to do at all, especially without a calculator. The algebra should be easy. This just becomes 2x when I integrate it. I want that from 3 to 1. Plug in my upper bound of 3, minus plug in the lower bound of 1, and I get 6 minus 2, which equals 4. I'm going to add that, because I got to add that to this integration. Okay, that's x squared minus x. I want that from 5 to 3. Okay, so x squared over 2. Don't forget that one. X squared over 2 minus x. Let's throw in the upper bound. 5 squared over 2 minus 5. That's the upper bound. Minus 3 squared over 2 minus 3. Okay. So I get 25 over 2 minus 5. This ends up being 9 over 2 but we need to distribute the minus sign to it, so it's negative. And then we need to distribute the minus sign to this, flipping it to positive 3. Right? Let's combine like terms. Negative 5 plus 3 is negative 2. 25 over 2 minus 9 over 2 is 16, is a positive 16 over 2, and that turns out to be 8. All right? So now it's just a matter of simple, I don't know, combining like term, adding and subtracting. 4 minus 2 is 2. 2 plus 8 is 10. Seemed like a lot of work. I mean, not a lot, but it seemed, the choice D is 10. It could have been easier. It could have been, if I graph this, here's 2. Okay, it's this line right here. I'll do this in red. Okay, and again, we're integrating this from 1 to 5, right? So here's 1, 2, 3, 4, 5. I could have done this, all right? All right, and then x minus 1, so I'll go down here to negative 1. We'll do this in blue. I'll start here, go up 1 over 1, 2. This is 1, 2, 3, 4. I wonder how high I'm going to have to go with this one. So up 1 over 1, up 2 over 1, up 3 over 1, up 4 over 1. There you go. Okay. Okay. I could have done the area under the curve. Here's 3 where it's split. I could have done this whole area under the curve. I should probably do this line. I could have done this area under the curve doing the triangle and the rectangle, and I still would have come up with 10. Okay? I still would have come up with 10, which when you're looking at it, it's easier, but you have to graph it, whatever. And you know what? I like practicing our integration anyways, especially when the algebra is very simple. Okay? And in this case, it was. Okay, number 14. If f of x equals a square root of x squared minus 4, and g of x equals 3x minus 2, then the derivative of f of g of x at x equals 3 is. There's 2 ways to do this as well. I could do a composition of functions first and come up with a new equation, take the derivative of that. Or I could take the derivative of this. The derivative of the outside and the inside stays the same, times the derivative of the inside. That's the chain rule. I could do that, or I can actually take g of x and plug it into f of x. Then take the derivative of this after I FOIL the inside and bring my square root to the 1/2. Let's work with smaller numbers. Let's work with this right here. All right, let's work with that and see what we end up with. Here we go. Da 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 da. All right, so the derivative, first of all, I want to find this at 3. So f prime of g of 3 times g prime of 3. All right, well, what's g of 3 first? G of 3 is 3 times 3 minus 2. That's 7. And it's 9 minus 2 is 7. So I need to find the derivative of f at 7. Okay, because g of 3 is 7. Now, what's g prime? G prime of x. Well, that's just 3. The derivative of this is 3. It doesn't matter what x is. That will always be 3, a constant. So it doesn't matter what number is in here. This is a constant, 3. Multiply that. Okay. Let's find the derivative of f. First of all, I'm going to rewrite this so that it's x squared minus 4 to the 1/2. Okay, my 1/2 comes down. X squared minus 4 to the negative 1/2 times the derivative of the inside, which is just 2x. Okay, let's rewrite this. Okay, I have my 2 on the bottom. This part comes down, and my negative 1/2 becomes a positive 1/2. Okay, times 2x, so I just put that in the top. We'll rewrite it again. My 2's cancel. I have x over the square root of x squared minus 4. Because anything, wow, anything to the 1/2 power is square root. Okay, that's the derivative of f. I need that at 7 now. So 7 goes in top, right here. The square root of 7 squared minus 4. Okay, that's going to be 7 over 49 minus 4, the square root of 45. Don't forget, this is just this right here. I still need to multiply it times 3. Okay, so this answer here still needs to get multiplied times 3. This right here is this right here. All right, so let's simplify that now. 21 over the square root of 9 times the square root of 5. The square root of 9 is 3. Oh, and that's perfect. 3 goes into 21 7 times. So I end up with 7 over the square root of 5. Whew. That wasn't that bad. And you know what? It was actually a lot less work than doing it the other way. Okay, so it is 7 over the square root of 5 right there. Choice A. Woo! Look at us flex our muscles without the calculator. Uh-huh. That's right. 15 states, the graph of a differentiable function of f is shown, well, not above, below and to the right. If h of x equals the integral from 0 to x of f of t dt, which of the following is true? Okay, so we need to find h of 6, h prime of 6, and h double prime of 6. Okay, and here's our h, right? So h of 6, let's do that first. If I put a 6 in there, that means wherever there's an x up top, I'm going to put a 6. That means I want the integral from 0 to 6 of f of t dt. Okay, that is the same thing as area under the curve of f. Here's 0, here's 6, all this area. I don't know what the exact value is. I just know that anytime the area is above the x-axis, it's considered positive. And anytime it's below the x-axis, it's considered negative. This is going to give me a negative number because it's below the x-axis. So h of 6 is negative. All right? Let's now find h, no, go to the thin one, h prime of 6, okay? Which means I got to take the derivative of our function. Okay, if this is h, I want the derivative of it, which is going to work out nice because these cancel, and so does this, and I end up with just f of x. In this case, we want x to be 6. So I really just want f of 6. That's this coordinate right here. When x is 6, my y is 0. So if h of 6 is negative, h prime of 6 is 0. All right? H prime of 6 is 0. So right now I know h of 6 has to be less, because it's a negative number, than h prime of 6. H of 6 has to be less. So I won't go canceling anything out yet. Let's figure out h double prime. Let's go back to here. Yeah. H double prime of 6. Well, if the derivative of h is just f of x, if I want the derivative of that, I'm just going to find the derivative of f of x. And they want that at a value of 6. Okay? So the derivative of f is the same thing as the slope of f at an x value of 6. Right here, That's a positive slope. That's increasing. That's a positive slope, which means it's a positive derivative. Okay, this is a positive number. Don't know exactly what it is, but I know it's a positive value. Okay, which means our negative value is the smallest, which is h of 6. That's the smallest. All right, 0 should be the middle term, h prime of 6, because that's 0. This we said was a negative value. And that both of those should be smaller than h double prime of 6, because we said that's a positive value. Okay, so that's what our answer should look like. And that, my friends, ooh, choice A. Love it. I don't know why I get excited when it's the first option all the time. Random. 1 in 5 shot. 16 reads, a particle moves along the x-axis with its position at time t, given by x of t equals t minus a times t minus b, where a and b are constants, and a cannot equal b. For which of the following values of t is the particle at rest? I hate when we get two unknowns. I just dislike it, especially on the final. But let's, show them what we're working with. All right, so first of all, particles at rest, that means the velocity is equal to 0. If I have position, I get velocity by taking the derivative of position, and that's the product rule. It is the first times the derivative of the second. Remember, that's a constant. Derivative of t is 1. Plus the second, just as it is, times the derivative of the first. Again, a is also a constant, so that's just 1. So I end up with t minus a plus t minus b. All right, well, that's where this should equal 0. When the velocity is 0, that's when the particle's at rest. And this is velocity. Let's clean it up. 1t and 1t, that's 2t minus a minus b. I'm just putting different symbols underneath there so I know I got everything. All right, and a value of t. I'm just going to solve this for t. That's all I can do. Look at my answers. They all have a and b in them. So let's add a, add b, add a, add b. We get 2t equals a plus b. And last but not least, let's divide by 2. Bam. T is equal to a plus b over 2. That's choice B. Now, that wasn't that difficult. I just like, when there are two unknowns, both are constants, blah, blah, blah. I really complained prematurely. That was pretty simple. All right. 17 gives us a graph of f. I love graphs and tables and charts. They're fantastic. 17 says, the figure above shows the graph of f. If f equals the integration from 2 to x of g of t, which of the following could be the graph of y equals g of x? So which one of these below is g? Keep in mind, look at the relationship of these two. If I have g of x, anytime I integrate something, I'm going backward, right? I integrate backward, which means if I were to go this way, that would be the derivative. Okay, so g is really the derivative of f, which means slope. Okay, g is the slope of f of x. And if you hit that, oh my God, it's easy. Here's a graph of f. G is the slope of f. Okay, so g is the slope of this graph. This is a constant. Not only is it constant, it's a constant that's positive. So if I want to graph g, if g is a constant that's positive, okay, let's pick a number, I don't know, 4. And I want to graph y equals 4. It's just going to be a horizontal line. B is a horizontal line, but keep in mind, here's the origin. That's negative. This is a horizontal line that's in the positive. It's choice A. It's not this, because it's a constant. Not this, not this. The big thing is understanding the relationship right there. Oh my goodness, thank God. Well, I mean, we didn't really need an easy problem. But after doing some complicated things, and there was always two ways to do a couple of the problems, now we got just a simple, straightforward thing. What I have before me in 18, the limit is h goes to 0 of the ln of 4 plus h minus the ln of 4 all over h. That is the definition of a derivative. Okay, this right here is the definition of a derivative. And we're used to seeing it like this. The limit is h goes to 0 of f of x plus h minus f of x all over h. They have put some value for x and h in here. Look at the first one. Okay, here's my h. This is when x is 4. Okay, this is the original function that I'm taking the derivative of. I am taking the derivative of ln of 4, by the way, when x is equal to 4. So I just need to find the derivative of the ln of x at x equals 4. Well, this is just 1 over x. And if I want x to be 4, man, that was a cakewalk. And let me tell you, if you haven't heard me say this on some previous videos, I love me some cake. Chocolate cake, ice cream cake, cheese cake. I love all types of cake. All right? I got to drop some pounds. Actually, I'm in pretty decent shape, but still, you know, you can never be happy with where you are. And it all starts with cake. All right, that's 18. Easy. 19 reads, the function f is defined by f of x equals x over x plus 2. At what point, or points, x, y, on the graph of f have the property, what points, x, y, on the graph of f have the property that the line tangent to f has a slope of 1/2? Okay. Okay. First of all, let's do this right here. Slope is derivative, so I got to find the derivative here. Let's use the calligraphy pen, because I love that, in case you haven't guessed. Low, d high, the derivative of high is 1, minus high, d low, the derivative below is just still 1. Draw a line, and I square below. Here we go. Let's clean up the top here a little bit. Okay, we've got x plus 2 minus x on the top over x plus 2 squared. All right, the good thing here is positive x and negative x cancel. I have 2 over x plus 2 squared. That's my derivative. What points is the slope or derivative equal to 1/2? In order for this fraction on the left to be 1/2, I mean, I can cross multiply, whatever, but in order for this to be 1/2, isn't 1/2 the same thing as 2 over 4? Like, doesn't that equal 2 over 4, 1/2? Yeah, so if the top is 2, the bottom has to be 4. So I'm going to take x plus 2 squared and set it equal to 4. And I'm going to solve for x. Okay, here. I need to undo the square, so I'm going to square root. So get x plus 2 equals, anytime you undo a square, it's plus or minus 2. All right? Now I got to just subtract 2. Boom. So I've got x equals, I've got two answers, a positive 2 and a minus 2, right? I'm subtracting 2 from both of them. 0 and negative 4. These are both x answers. All right? Now, if I look here, there is only one option that gives me an x of both 0 and negative 4, and that's choice C. Okay, 0 and negative 4, that's choice C. So that was 19. I mean, that wasn't bad. It was a little bit, you know, almost seemed like a free response question type of answer, okay? Almost seemed like that. Last problem, number 20. Let f of x equal 2x plus 1 cubed. Okay. Let g be the inverse of the function of f. Anytime I see this, okay, anywhere there's going to be a g in the future here, I'm just going to write it as the inverse of f, okay? Given that f of 0 is 1, okay, this is a coordinate. What is the value of g prime of 1? So that's the inverse prime of 1, because anytime there's a g, I'm going to write that. So I'm finding the derivative of the inverse of f at 1. Anytime I need to find the derivative of the inverse of something, I write it as 1 over the derivative of the inverse of my x value. I write it just like I say it, with a 1 over, okay? 1 over the derivative of the inverse of f, in this case where x equals 1. The first thing, and do this in steps, please. Take your time, let's find this, because I can find the derivative of f. That's easy. But let's find the inverse of f, and this is what we got here. This is helpful. If I want the inverse at 1, I'm finding this right here, because whatever this is, it's going to go in here for the derivative, or excuse me, the inverse of f. I go to the original equation, and I flip my x and y values, meaning this comes here, it's a 1, and whatever this is going to go here. This is where I look here. They tell me f of 0 is 1. F of 0 is 1, which means this is now going to come here, okay? This should be inverse, okay? The inverse of 1 is 0. So this whole thing I'm going to replace with a 0. First, let me go back and make sure you completely understand this inverse part, okay? This f of 0 is 1. That was given to me right here, okay? And for any type of inverse, the x and y flip. So if I want to find the inverse of f at 1, that means this flips over here, which means this has to flip over here. All right? I don't know why I feel like I need to say this a lot. Maybe I feel like it's not clear. If I know this, then the inverse literally just flips these two. And I needed this. Okay, literally they just flip. Okay, I needed this value, 0, for my denominator right here. Okay, now I need to find the derivative of f and plug a 0 in for it, and that's going to be my denominator, and I will be done. Okay, so let's find that derivative of f. Here's f right here. I got to find the derivative of that. So f prime of x. The 3 comes down. I've got 3 times the inside stays the same. I subtract 1 from that exponent times the derivative of the inside, which is just 2. Okay? I want this at an x value of 0. So 3 times 2 times 0 plus 1 squared times 2. 0 plus 1 is 1. 1 squared is 1. 3 times 1 times 2, 6. That's f prime of 0. That's exactly what I want for the bottom here. There you go. I think the reason I felt the need to over-explain the inverse is because there's a lot of highlighting going on here and a lot of movement and arrows. But this right here seemed just really, really clean. All right? So that's it. We're done. Okay, we're done with questions number 11 through 20. Don't forget, ring the bell. That helps me. Leave a comment down below if you want to see anything else. Follow me, that helps you. And I'll see you for the next section. We do 20 through 28. Peace out.